Hi, and a very good morning to everyone. We are from the engineering science class, and today we would like to present our mini project entitled Hydraulic Lifter. This project is based on chapter 4, which is Work, Energy, and Power, and it applies the concept of Pascal's principle in a simple lifting system. A hydraulic lifter is a device that helps lift heavy loads with a small force by using fluid pressure. Our aim is to show how the principle works in real engineering applications such as car jacks, hydraulic lifts, and workshop tools.
Our project model is built using two strings, a plastic tube and water as the hydraulic fluid. The smaller string acts as the input piston and the larger string acts as the output piston. When we press the small string, the water transmits the pressure to the larger string, causing it to push upwards. This system works according to Pascal's law, which states that pressure applied to an enclosed fluid is transmitted equally in all directions. The relationship between pressure, force and area is shown in this formula. P equals to F over A. Therefore, when the area of the output piston is larger, the output force increases, even though the input force is small. This principle is what allows hydraulic system to lift heavy objects easily.
For our project, we use several simple and easily available materials. These include two strings, one with 10 ml capacity and another with 50 ml, a short flexible plastic tube to connect them, cardboard and recycled plastic for the base, and water as the hydraulic fluid. The total cost of all the material is 50 ringgit only, which make this project very affordable for students. We try to use recycle and reuse items wherever possible, so that our project is not only cheap but also environmentally friendly. The process of building the model took about 2 hours. We spent time testing and adjusting the design to make sure the system worked smoothly without leakage. We also choose water as the fluid because it's safe, clean, non-toxic, and easy to refill. It is a good choice for small-scale experiments like ours. Overall, this project shows that we can apply engineering and physics concepts even with low cost and recycled materials. It proves that science learning doesn't always require expensive tools. Only creativity, teamwork, and understanding of basic principles.
During testing, we press the small string and the larger string move upward smoothly, lifting the load on top of it. This shows that the pressure applied at one point of the fluid is transmitted equally throughout the fluid. As explained by Pascal's principle, we observed that the output force was several times greater than the input force, proving that our hydraulic lifter provides a mechanical advantage. However, we also noticed some minor energy loss caused by friction between the string and the piston, air bubble trapped inside the tube, and a small amount of water leak. This factor reduced the system efficiency slightly, but the filters still work well and demonstrated the conversion of energy where the total work done remained the same.
In collaboration, our hydraulic lifter project has successfully demonstrated in the real life application of Pascal principle, work and energy. Through this experiment, we proved that a small force applied on a small piston can lift a larger load on a bigger piston by using equal pressure in the fluid. This principle is the foundation for many hydraulic machines used today. For example, in automotive workshop, hydraulic jacks are used to lift cars for maintenance. In construction, hydraulic lift used to raise heavy material. And in factories, hydraulic system power, press, lift, and robotic arm. Then, from this project, we learn more than just the theory. We develop hands-on skill, learn to work as a team, and understood how simple physics can be applied to solve real engineering problems. We also learn to manage low budget because our project only cost 50 ringgit. Yet, it was still effective and eco-friendly. This project challenged us to think critically because we had to deal with leak, our air bubbles, and friction issue. But through testing and discussion, we improved the design step by step. It made us realize that engineering is not just about building, it's also about problem solving, testing, and improving.